In this brief demo, we're going to look at how automatic classification and indexing technology can be applied to medical records. We have a patient file here that's been scanned in, and for this demo we've also redacted the document to remove any patient details for confidentiality reasons. If I open up the document, we can take a look at the contents. The document has been OCR'd to extract the raw text from each page, but has had no other automated processing at this stage. If we scroll down here, you can see that this particular patient file is fairly large. It has 561 physical pages, which results in 1,122 images altogether when we include both the front and the back of each page. You can also see on this tab that there are no bookmarks at this point in this document. So let me close this file now, and what we're going to do now is to pass the file to the automated classification and indexing technology, and we can take a look at that process. Here we're going to take the raw file and extract from it page type and other information that will make the record much easier to navigate. So first of all, you'll see it's loading in the file. It's about 300 megabytes or so it'll take a few seconds to read that in. When that's done, it's going to make a first pass through the file to extract any data that may help in indexing. In particular, we're looking for any relevant dates on the documents, and we also have a database of consultant names for this particular hospital, so it's going to look for matches against any of the consultants' names on every page. You see here that it's pulled out a number of dates and a number of consultant names. Now it's making a second pass through the entire file, classifying every page. For each page, the classification engine is showing what it believes the document type to be, and a number which indicates its confidence in that result, how good the match is, if you like. We'll see how the confidence value is used later. You see it going through here. It takes a little longer on the history sheets because it's doing some extra processing on these, which we'll see later. But once it's through those, you'll see that the classification process itself is extremely fast. So now that's complete, and it's writing out a new version of the file with the results embedded in it. Okay, so you can see here the new file that's been written. So let's take a look at the results. You'll see the new file now has bookmarks in it showing the classification and extraction results. If I collapse the view here, you'll see the technology is located in the tabbed separators and been able to keep the original file structure. If I expand this section, you'll see there's a further breakdown into specialities, again determined from the separators. Within this, we have the individual sheets, and these are identified to a fine level of detail. You'll see some of the pages, such as this one, are also labelled with a date. And if I scroll down here, you'll see that the technology has located and extracted the relevant date of the document. This data can be used to create a timeline or episode-based view in a patient record system. The history sheets you see here often have handwritten dates. And while we're not actually reading those in this demo, what you can see here is that the system has located the area for the date. This could now be passed to an ICR engine for automated recognition, or if necessary to a human for manual keying. If we now move down to the correspondence section of the file, you can see that in many cases the system has automatically extracted the consultant name, making it easier for clinicians to review the relevant correspondence. And you see again that the appropriate date has also been captured.